and it's going to be a lot of factoring, so this video might be actually a little bit long. If you guys feel comfortable with any certain part of the video, then you can just skip ahead. My suggestion might be to maybe watch the video, but just do it at two times the speed, just so that things can go a little bit quicker. If you remember how to do stuff, then you can just skip that part. If some stuff has been pretty old where you're like, oh hey, I kind of remember that but not exactly, then just make it normal speed, maybe pay attention to it a little bit, and then if you come to another part where you understand things again, then just keep moving forward. Alright, so this is going to be Algebra 2 7D. Determine the linear factors of a polynomial function of degree 3 and of degree 4 using algebraic methods. So we're not gonna try to do bigger than degree 3 and degree 4 for this class. I will talk about the graphs of higher degree polynomials, but later on. But for now, whenever we're factoring, it'll be at most degree 4. Alright, so before we start looking at degree 4, we are going to talk about what it means to factor a polynomial completely. Okay. Well, to factor a polynomial completely, or to have it be completely factored, means that it's written as the product, or like the multiplication, of unfactorable polynomials with integer coefficients, which basically means that it's broken up into pieces that can't be broken down any further without having you write down fractions or decimals. Okay. Factoring things out completely is actually going to help you figure out what all the linear factors of a polynomial are. Okay. Not all the factors of a polynomial are going to be linear. Okay. Some of them are going to be quadratic, and although I'm not sure about this, I don't think any of them should end up being cubic in the end. But oh well. Let me continue. So an example of some polynomials that are factored completely is already up on the screen. Right here we have 2 times x plus 5 times x minus 3. That's already factored completely. This is because x plus 5, I can't break it down to anything less than x plus 5. Okay. If I did, then I would start using decimals or fractions. Like, let's say I took out a 5 from this. Well, factoring out a 5 would give me x divided by 5 plus 1. And yes, this does seem like it'd be smaller than this. But like I said right here, we want integer coefficients. So if we don't have an integer coefficient from the x, then it's not really a completely factored form. Okay. The x minus 3 has the same thing. I can't break it down any further without starting to use decimals or fractions. And now on the other hand, if we have something like this, 3x times x squared minus 4, this is not completely factored out, because this x squared minus 4 can still be broken down into the smaller pieces. And by smaller, I mean polynomials of a smaller degree. Okay, now x squared minus 4 can actually be turned into x plus 2 times x minus 2. Okay, because this is the difference between two squares. Basically, anytime that you have something like this, you can write it down as something like this to factor it out. Okay, and I'll go over that a little bit later, just in case you guys have not remembered it or have already forgotten it. Alright. So why do we want to factor out polynomials, or why do we want to know those linear factors? Well, when a polynomial is factored out, it's really easy to figure out what the solutions to the polynomial are whenever it equals to 0. Okay, this is due to the zero product property, which basically says that if the result of something you multiplied is equal to 0, at least one of the numbers that you multiplied has to be equal to 0. So let me put up an example up here on the corner. Okay, so let's say we had 0 times 5. Okay, This equals 0 because one of the numbers was equal to 0. Okay. I could have gotten the same result from both of the numbers being 0. Okay, but if I have any numbers that are not equal to 0 being multiplied together, like let's say 2 times 3, the product will never be equal to 0. So basically, one of them, or at least one of them, has to be equal to 0 in order for your result to be equal to 0 whenever you multiply two numbers. Okay, now the same thing happens for whenever you have factors, for whenever you have polynomials. You see, if you set x squared minus 4 equal to 0, well then we could say that x plus 2 times x minus 2 equals to 0. Okay, and this now is a multiplication of two numbers. And numbers, you don't see me, but I meant to say them with quotation marks. So they're quotation marks, numbers, and quotation marks. Okay. Now, in order to get 0 from this, one of them has to be equal to 0, or both of them have to be equal to 0. So that's why we end up setting them equal to 0 to solve for x. Okay. Okay. So we get x equals negative 2, x equals to 0 as our solutions for this equation right here. Okay. Now if I had not known that this was the factored out form of it, then it might have been a little bit more difficult for me. Okay, this is because I would either have had to guess and check, I would have had to look at a graph, or I would have had to use the quadratic formula on this to get the solutions. Okay, all of those are really slow. I'd rather look at the factored form, look at the linear factors, and then set them equal to 0 to see what my solutions would be. Okay. The next 3 points I think are another example. Okay, you see if you had x squared plus 3x plus 2 and we set it equal to 0, well, we can factor out the equation on the left hand side, and if it follows the 0 product property, well then x plus 1 can be equal to 0 and x plus 2 can be equal to 0, and as long as we solve for x here, we can get the solutions for the equation at the top. Okay, now here's some review. Okay, this is the part where you guys can go back, go forward and just skip around. Okay, if you already know how to do this, then you don't have to watch this part. Okay, just skip a few minutes in, or do ×2 playback. Okay, so factoring. Okay, this one's the easy way of factoring. Let's say you had a leading coefficient of 1, meaning that the number in the front right here was a 1. Okay, if you have this type of equation, all you have to do is take a look at the last number, in this case 3, and take factors of it. Okay, what numbers multiply together to give, what two numbers multiply together to give you 3? Well, 3 is a prime number, so really only 1 and 3. Okay. By the way, you want to keep them as integers, so whole numbers. Okay, so don't use 2 and 1.5. You want integer values. You want whole numbers. Okay, so let's go ahead and split this off. Okay, now that we have 1 and 3, we have to make sure that they add up to the number in the middle. Okay, sometimes you're going to have more than 2 numbers, more than one pair of values that multiply to give you the last number over here, the constant. And in those cases, you just want to take the sum of the values and make sure that they give you the number in the middle. Okay, don't just choose any random one, because that's going to give you wrong factors if they're not the correct ones. Okay, so 1 and 3 give you 4. Okay, so that's great. That's 4 is the number that we wanted. So we can separate this into its factors of x, and then since this is a positive 1, it'll be plus 1, and since this is positive 3, this other factor would be x plus 3. Okay, if they were negative, like let's say it was negative 1 and negative 3, then our factors would be x minus 1 and x minus 3. Okay, and now this problem does not use those negatives, so don't get them confused for this one. But yeah, this would be our final completely factored form of the equation right there. Okay, now let's step it up a little bit. Okay, what if we had 1x squared minus 7x minus 30? Okay, the number in the front is still 1, so we still want to look at the last value. Make sure that you include your negative. And we're just going to factor this out. Okay. Whenever you're factoring, ignore the negative for now at the beginning. We'll deal with that at the end. So just take 30 and split it off. 1 and 30, 2 and 15, 3 and 10, 4 doesn't fit into 30, 5 fits into 30, 6 times. And then if we keep going, I would say 6 fits into 30 5 times, but I already wrote that down. I already wrote down 5 and 6, so I don't want to rewrite them. Okay, so these are all your factors of 30. Okay, what we want is negative 30 though, so we need some of these values to be negative. Of course, whenever we add them, we also want them to add up to the number in the middle, negative 7. Okay, because this is a negative value, I'm gonna want the negative number to be the higher value. So I'm gonna put negatives on all of these values on the right side and add them up. Okay, if I don't end up getting negative 7, what this means is that the equation can't be factored. So this would actually be completely factored out at that point. Okay, so we have 1 minus 3 minus 30, or 1 plus negative 30, which gives me negative 29. That's not negative 7, so we just move on. 2 plus negative 15 is negative 13. That's not negative 7, so we move on. 3 plus negative 10 is negative 7. That is negative 7, so these are going to be part of our factors. Since it's a positive 3, this means that we'll have x plus 3. And since that's a negative 10, this means that we'll have x minus 10 as our other factor. Okay, and that's what I was talking about over here, the stuff that I scratched out. Okay, so that's our completely factored out form of the equation. Okay, so hopefully you remember that part at least. Okay, then we have factoring out an integer. Okay, so let's say you look at a problem and you notice a specific pattern. Okay, I look at this equation and I'm thinking, you know what? I know my multiplication tables really well, and I know that all of these coefficients and the constant are multiples of 3. 3 times 1, 3 times 2, 3 times 1. Okay, I think I can factor out a 3 from here, meaning I can take out a 3, writing it off to the side, and then divide every single one of these terms by 3. 3 divided by 3 is 1, so we have 1x squared. 6 divided by 3 is 2, so we have 2x. And 3 divided by 3 is 1, so we have plus 1. Okay. So by doing this, I can actually make the problem a little bit easier. Okay. Every single term was a multiple of 3, so I can take out a 3. The same thing can happen for any other values. Whenever you see multiples of 5, you can probably take out a 5. Whenever you see multiples of 6, take out a 6. If you see multiples of 2, meaning that every single one of the values is even, do the same thing. Take out a 2. Okay. Now these two equations are the same, but this is not completely factored out. Okay, you see this part can still be factored out further. Okay. Now, because we have a 1 in the front, this means that I only need to look at the constant term in the back and factor it out. 1. The only way I can get 1 is by taking 1 and multiplying it times 1. If I add up these two ones together, we get 2, which is the number that's in the middle. That's the number we want. So it turns out that our factors for this part of the equation would be x plus 1, x plus 1. Because we still have that 3 in the front, I'm going to go ahead and add that in. And this is our completely factored form of this equation, and that's how you factor out a number, an integer. This just makes your problems a little bit easier sometimes. You know, you want to work smarter, not harder. Alright, now let's say you can't factor out an integer. That's whenever you start using the AC method of factoring. Okay. So take a look at this. We have 2, we have 3, we have negative 20. There's no number that divides 2 and 3. So therefore, the AC method is what's going to work for this problem. Okay. What you want to do is take your number in the front, take your number in the back, and multiply them together. 2 times negative 20. Well, that's negative 40. Okay. From this value, negative 40, you're going to go ahead and take the factors of those values, just like we did for the first slide. Negative 40, well, we're going to ignore the negative for now and just write down the factors of 40. 1 and 40. 2 and 20. 3 doesn't fit into it, but 4 does. So 4 and 10. 5 and 8. 6 doesn't fit into it. 7 doesn't fit into it. 8 fits into it, but I already wrote it down, so I'm just going to leave it as this. Okay. Now, just like before, we're going to pay attention to this middle value again. Okay. Positive 3 is what we want. And we have a negative 40, so we're going to need to take one of these values and make them negative. Okay. Now, I want a positive 3. So most likely I want the smaller number to be the negative value. That way whenever you add up the two numbers, you get a positive. So that means this side should be negative. By the way, if you're not sure how to tell which one should be negative, you know what? Take a guess. Make the left side negative first. If you don't get it right that way, then make the other side negative and those positive, and check it again and see if you get that number in the middle. Okay, again, if you're not able to get the number in the middle, it probably means that it can't be factored, or at least it can't be factored further, and it's already completely factored out. Okay. In those cases, if you have a quadratic equation, whenever you can't factor it out further, that probably means that you want to use the quadratic formula to solve for it. Alright, so we have negative 1 and 40. That's going to give me 39. Negative 2 and 20 gives me 18. Negative 4 and 10 gives me 6. And negative 5 and 8 gives me 3. Okay, positive 3 is what we wanted, so these are going to be the values we want. Okay, now don't skip ahead just yet, because these are not part of our factors. They're actually just used for, we actually plug them back into the original equation. Okay, like this. Okay. So we have 2x power of 2 minus 5x plus 8x minus 20. Why did I change that 3x into minus 5x plus 8x? Well, it's because they're still the same value. Negative 5x plus 8x will give you 3x. But it allows us to do factoring by grouping. Meaning that if I take this group and I take this group and factor them out individually, I'm able to see if they have a common factor between both of them. Okay, and I'll show you what that means in a bit. Okay, so first, again, just like before, we're going to try to factor these out, see if there's any common values that will divide both numbers. Okay, 2 and negative 5, they're both prime numbers, 2 and 5. So that means that I can't factor out a value that will divide both the 2 and the 5, so I can't take out any numbers. Though, because both terms have an x, this one has 2, this one has 1, I can factor out an x. So I'm going to write down x, and then inside of a set of parentheses, I'm going to write down what's left over. 2x squared divided by x will give you 2x. Negative 5x divided by x will give you minus 5. Okay. If you continue onto the other side of that line, we can do the same thing. What number divides both 8 and 20? Well, 1 divides both of them, but you want to go higher than that. So 2 divides both of them, but let me go ahead and write that down over here. It divides 2, it divides 20. Well, let's see if we can get a bigger value. Normally you want to stop once you get to the smaller of the two numbers. So if I get to 8 and I don't have any numbers that divide both of them, then just assume that you can stop there. Okay, so we have 8. Let's see, 3 doesn't divide into 8, so that one can't be it. 4 can divide into 8, and it can also divide into 20. So I'm going to factor out a 4 at this point. I'm going to keep going just to check to make sure that I can't factor out a bigger value. 5 cannot divide into 8. 6 cannot divide into 8. 7 cannot divide into 8. 8 can divide into 8, but it can't divide into 20. So actually the biggest number that we can take out, or that we can factor out, is a 4. So I'm going to go ahead and write that down over here. Because it's a positive 4, I'm going to write down plus 4. And then divide both of these terms by 4. 8 divided by 4 is 2. And then since we have an x, I write it down. And then negative 20 divided by 4 is negative 5. Okay, now notice that the terms in here are the same terms as the ones in here. Okay, so that's what I mean by they have a common factor. Okay, so this side of the equation and this side of the equation both can factor out a 2x minus 5 and a 2x minus 5. So I'm going to go ahead and do that. I'm going to write it down off over here. And then everything that was inside parentheses before, I'm going to write it down in its own set of parentheses. X plus 4. At this point, that's it. 2x minus 5, x plus 4, that's our final answer here. Okay. Alright, now the next problem. Okay. One of the things that you might notice whenever you look at this problem, if you're good at your times tables, is, well, we have 3 times 1, we have 3 times 7, and 3 times 10. If you didn't notice that, well, that's okay. Starting it off this way again would have been fine. But remember, if you can work smarter, then you should. Okay, so we have 3 times 1, 3 times 7, 3 times 10. I'm going to go ahead and factor out a 3. We have x squared plus 7x plus 10. Okay, now we have a 1 right here, meaning that we can use the regular version of factoring out values. But just for the sake of it, I'm going to go ahead and use the AC method on the inside of this parentheses. I'm going to take 1 and I'm going to take 10. I'm going to multiply them together and just factor out the values. So 1 times 10 is 10. Our factors are 1 and 10, 2 and 5, and that's it. Okay. I want two numbers that whenever you add them up give you 7. This is 11, this is 7. These are my numbers. Okay. Now I'm going to use the AC method, but at this point I already know that the factors are going to be x plus 2 and x plus 5, and then the 3. Yeah. But I'm going to keep going, just like I said, for the sake of using the AC method here. Okay, so we have 1x squared plus 2x plus 5x plus 10. Okay, I'm going to write down my dotted line in the middle and try to factor out the numbers on the left hand side, try to factor out the x's, and then do the same thing on the right hand side. Okay, now 1 and 2 have no common divisors, so I'm going to go ahead and not take out any numbers. Okay, well, 1 is a common divisor for both of them, but, or a common factor for both of them, but it doesn't do anything if you divide 1 by 1 and 2 by 2. I mean 2 by 1. So we have 1x squared plus 2x. They both have an x, so I can take out an x. And then we have 1x plus 2. You can also just leave that as x plus 2 if you want to. Okay. On the left hand side, well, we have 5x and we have 10. And hey, look at that. 5 is 5 times 1. 10 is 5 times 2. See? I can actually factor out a 5 because they both have a common factor of 5. So I'm going to do take out a positive 5. And this is going to leave me with 1x, or just x, and then plus 2. Again, we have a common factor like we did over here. Okay. So I'm going to go ahead and take that x plus 2 and take it out of both sides of this line. Factor it out. And then whatever wasn't in parentheses before, I'm going to write it down in its own set of parentheses. So we get x plus 2 and x plus 5. We had the 3 in the front, so I'm going to go ahead and put that in there. That's our final factored form. If you decided to use the AC method right from the beginning, by multiplying 3 times 30 and taking all the factors of 90, you would get to the same result. It would just take you a little bit longer. Okay, that's fine. You know, an SAT test, you might want to work hard faster, but at the same time, if you don't feel comfortable with going a little bit fast, then, you know, going and doing the correct thing to do is probably better in that case. Alright, so yeah, that's the AC method of factoring. Okay, and so now to the real lesson, factoring a polynomial completely. Okay, now whenever you want to factor out a degree 3 or degree 4 polynomial, it may be efficient to use synthetic division to make the rest of the polynomial easier to factor. Okay, this is only whenever you do know a factor of the degree 3 or 4 polynomial. So let's say you had something like this: x cubed plus 8x squared minus 29x minus 180. Okay, what if I told you that x plus 9 is a factor? Okay, well, if you know that x plus 9 is a factor, well, then take x plus 9, set it equal to 0, and solve for x. This essentially gives us x equals to negative 9. I'm going to put that negative 9 over here. Inside of the L, or inside of the synthetic division, I'm going to use 1, 8, negative 29, and negative 180. Yeah. Now, some of you guys have made the mistake of dividing by this number right here. Notice I said that's a mistake, okay? Because you want to divide by the number that's right here. Okay, this happens at the very end. Once you know all the values underneath the L, you want to divide by this number for all the values that are not the remainder. Okay, so we're going to divide by 1 at the end. And if you divide by 1, it's not going to change anything. So I'm just probably going to skip that part. Okay, if we had had 2x plus 9, then I would probably not forget about dividing by 2, because that would make a difference. It would make a difference. Sorry if you couldn't hear that. Alright, so let me go back to my pen. Alright, so the first number you want to bring down to the bottom, 1, 1. And then we're going to take this negative 9, we're going to multiply it onto the numbers on the bottom. Negative 9 times 1 becomes a negative 9. And then we start adding the numbers on the inside. You should already know this by now. Okay, so I'm going to go ahead and do it. Negative 1, this is going to become positive 9, negative 20, 180, and then 0. Okay, this remainder of 0, the last value being 0, is not a surprise to me. If you know that something is going to be a factor, like it is here, then you should always have a 0 as your remainder. Whether you're doing long division or you're using synthetic division. Okay, so now we have 1 minus 1 and negative 20. This actually stands for 1x squared minus 1x minus 20. Okay. But this doesn't actually tell us all the factors, all the linear factors of the polynomial right here. But it helps us. Let me see, do I have extra space? Yes. So we know that this polynomial is actually equal to x plus 9 times 1x squared minus 1x, and then was it minus 20? Yep, minus 20. Okay, we know one of the factors, and now we can probably try to split this factor out, this quadratic polynomial. Okay, since we have a 1 in the front, all we have to do is take the 20 in the back, negative 20, and factor it out. We can have 1 and 20, 2 and 10, 4 and 5. Because we want a negative 20, one of these is going to have to be negative, and since we want the sum of them to be negative 1, the big value is probably going to have to be the negative value, so that whenever you add them, you end up getting a negative value. So this is going to give me 1 and negative 20 becomes negative 19, 2 and negative 10 becomes negative 8, and 4 and negative 5 becomes negative 1. Exactly the numbers that we want, meaning that these are going to be part of the factors of that quadratic. So x minus 5 goes here, and then don't forget about the x plus 9. We don't have any numbers in the front because we didn't factor out any integers. Okay. So yeah, that's how you would take a factor, use synthetic division on a higher degree polynomial in order to factor it out more completely. Okay. And the same thing works if you know more than one factor for a bigger polynomial. Okay, so suppose you wanted to know the factor, you wanted to factor this equation, and you knew two of the factors. You knew that x plus 7 is a factor, and you knew that x minus 4 is a factor. Well, just take those two factors and set them equal to 0. Okay, solve for them. And we'll get x equals to 4. Okay, x equals to 4, and we get x equals to negative 7. Now here, it doesn't matter which one you choose to use first. You're going to use them both anyways in the end. So just pick and choose whichever one you like best. I kind of want to work with the 4 first, so I'm going to use that one on the outside. Oh, by the way, I'm not dividing by anything at the end like I did earlier, because right here we have a 1, right here we have a 1. So dividing by 1 is not going to change the values. Let's say 3 divided by 1, that's still equal to 3. So whether I do it or not, it doesn't matter because it's redundant. Alright, so inside of the L, I'm going to go ahead and write down the numbers for the original polynomial. Okay, so 1, 8, negative 7, negative 122, and negative 168. Okay, I already know that the remainder is going to be 0, so I got to make sure that I get 168 right here at the end. Well, let's go ahead and go back. You bring down the first number, 1, and then start multiplying the numbers on the outside. 4 times 1 is 4, 8 plus 4 is 12, 12 times 4 is 48, negative 7 plus 48 is 41, 41 times 4 is 164. Oh, that's a positive. And then this gives you 42. Negative 122 plus 164 is 42. 42 times 4 will become 168. So, just like I said, we were going to get a remainder of 0. Negative 168 plus 168 cancels itself out. You get 0. But 0 is there because, you know, we already know that this is a factor. Okay. So, 1, 12, 41, and 42 actually stand for 1x cubed plus 12x squared plus 41x plus 42. Okay, it doesn't matter that you write this part down again, or it doesn't matter that you write it down like this at all, because we're going to end up using those numbers anyways, the coefficients, once more. So you don't do it with the original values, you're going to do it with the new values, and you're going to use that negative 7 now. Or if you started off with negative 7, you would use the 4 at this point. Okay, so we'll have 1, 12, 41, and 42. Okay, so we bring down that 1 and start multiplying the numbers on the outside. Negative 7 times 1 is negative 7. 12 minus 7 equals to 5. 5 times negative 7 equals negative 35. And 41 minus 35 equals 6. 6 times negative 7 becomes negative 42. Sorry if that's a little fast. I'm just trying to get through this quickly because I don't want you guys to watch a hour-long video. Okay, so we have 1, 5, and 6. 1x squared plus 5x plus 6. Okay, so now this is a much easier problem to factor out. We know that these two were factors of this problem, and we know that this is a factor of that problem as well. But now we can try to see if we can completely factor it out, or if it's already completely factored out at this point. Okay, so since we have a 1 in the front, we're going to take the 6 in the back and just get the factors of it. 1 and 6, 2 and 3. We want them to add up to 5. And to do that, we're going to use the 2 and the 3 values. This means that we are going to have x plus 2 and x plus 3 as our factors. So if we wanted to completely factor this equation out, we would write it down like this. X plus 7, x minus 4, x plus 2, and x plus 3. Does the order matter for this? No. You can have the x minus 4 in the front if you want to, and the x minus x plus 7 at the end, because multiplication is commutative, so it doesn't quite matter. Alright, so there we go. That's it. That's using synthetic division to figure out some more factors of a polynomial. Okay. Given that you know some factors already. I'm going to stop the lesson there, but I'm going to continue talking about factors on the next one, and some different factoring methods that I think you guys might not remember, or that we might have not seen just yet. Okay. Until next time, you guys have a good day, and stay safe, wash your hands.